Hey everybody, this is Larry. This is the 5th day of the June Leetcode challenge. Uh, let's get started. Hit the like button, hit the subscribe button. Let me know what you think. Random pick with weight. Given an array W of positive integers, where weight W sub I is the weight of index I, write a function pick index which randomly picks an index in proportion to its weight. Okay. I guess this one is kind of hard to check, as long as it's just a random character. But so the first thing I would say is, given that we're in Python, there is actually a Python library that does this. I'm not going to get into it because, you're probably watching this video not so that we're like, Larry, tell me which library in Python do you use for this very specific problem, right? But yeah, let's kind of think about it. I think there's a couple of clever ways to do this. There's actually something also called reservoir sampling that you can play around with, so that actually you could get it done all in one space. I would have to prove, to be honest, I would have to prove that from scratch. I have vague ideas of it, but I'm not going to do that now. Definitely, leave a link below, do your Google research, Wikipedia, learn about that, and play around with that idea. I think it's a very cool idea, and you can prove it on your spare time too. It's actually not that difficult, per se, in theory. But that said, I'm just going to do it probably one of the ways that I would do it. And the idea is just, well, for each weight, let's calculate the prefix sum, and then roll a number between 0 to the sum, maybe sum minus 1, and then just kind of, you could do a binary search to see which weight that you get into, because if you look at the prefix sum, it's going to be monotonically increasing, and then we have a number. You have to find the bucket in which that number is on. That number is the first bucket that is the sum. The prefix sum is smaller than this random number, right? Okay, let's go around that. Does that kind of make sense? Because the idea behind this is that, okay, the idea is that, let's say you have some weight. Okay, well, this weight is useless, but let's just say random numbers, or not random numbers, but like random to Larry generated numbers, something like this, right? Not even that random enough, but then now you do the prefix sum, 16, 31. Now you pick a random number. I mean, I guess technically there's a 0 prefix sum. Between 0 and 31. And then that will allow you to kind of figure it out which bucket to fall into. So in this case, this actually matches up with this, because and the 31 is kind of implicit. You don't need to actually create a prefix sum that way. But the idea is that, okay, how many numbers are between two adjacent numbers, right? Well, the numbers between two adjacent numbers, by default, because we're prefix sum, is the weight that we're given. And then now, so then in that case, and then now you take the sum of the entire array, which is actually just the last number, because it is a prefix sum. That's the definition of prefix sum. So that means that the first array will give you 1 over the sum, which is 1 over 31. The delta here would be 5 over 31, 10 over 31, and so forth, right? So that's kind of the idea of how to do it. And as you can tell, because it is a prefix sum with positive numbers, it's going to be monotonically increasing, which means we can binary search. So let's do that. So let's initialize this weightless. So yeah, what happened there? So let's just do ourselves that prefix is equal to 0 for W, and it's literally called W. So okay, let's rename this W and weights. Self.prefix dot append weight plus self.prefix, the last element. So basically what this is doing is it just takes the last element and then adds it to the current element. Just a way of writing prefix sum, not a big deal. And then pick index. So is it just like pick a random one? Okay. And then now, oh, let's just also get, I guess the sum is equal to, yeah, we could do it. I just want this to be a little bit more explicit though. Again, this is a very obvious thing, and that in a prefix sum, the sum of the entire array is just the last element, right? And now let's pick a random number from 0 to self.sum. Actually, don't know, don't remember how to do random in Python, so let me look it up random really quickly. I think it's just random.ran or something. Right? Oh, random.randint. Oh, right. There are a couple of random functions, so that rand range. Okay. Yeah, I think this is good. I could be wrong and or off by 1, but I'm just reading the syntax right now for random.random. Here's what I'm reading in case you want to read it with me. And again, this is what I was talking about. You could do random.choice with random.choice, and that'll literally be the answer with the rates. The cumulative rates are again prefix sums, but I mean, that kills the point a little bit if you do it this way. But I mean, a little bit. I mean, you should, especially for an interview, you should do this. But of course, on competitive programming, then maybe you just use the random.choice, and that's fine. But yeah, so I think random range should be okay. So let's just say number is good, maybe. Okay, and then now let's binary search. So head is 0, 0. That's just how I write it, but feel free to write it your own way. So mid is equal to plus 1 over 2, and then if. So basically, what do we want, right? This is the prefix sum. Let's say we find 8. Well, we want it to be 6. So basically, if we're in the middle and we want to find 8, then this actually just means that if this is smaller, then what does this mean? That means that, yeah, all the numbers before it are smaller, so we actually just want this side, given that this is smaller. So that means that head has to move to the middle. So, okay. So if self.prefix of mid is greater than or equal to number, then we move head to mid. Else, let's say, given another one, let's say we're here, and this is bigger, well, then we know that it cannot be 16, and we want it to the left. So now we want the tail to be mid. The is me double checking that this is correct. It's a little bit off because this will never converge. What we want, because the tail is just saying this, but then because we never moved the head, so if head and tail is equal to 1, so then we have to add 1 here so that we double check. Okay. And then now we should be okay with returning head as the index once that happens. Let's put in some test cases. Okay. Let's try. Let's see. I mean, it's still either way we have to fix it, but oh, I guess this could actually. Let's see if this is 0. This is n. Then yeah, this may be. So yeah, this is 0, this is 2, then this will give you 1. No, that should be okay. What? Why is maybe. I mean, it's clearly not okay, but let's debug this real quick. Oh, because it goes from 1 and then 2. Then this would never terminate, right? Binary search off by ones are tricky, so we have to make sure that that we're okay. This might give us a time limit exceeded, which is what I viewed, but that means that this is right. It's just that if this is the case, then that doesn't seem very random, though. But oh, this is returning the biggest thing in either case. What is that? What am I printing with number, or what am I randoming with number? For 0, this is 2. That doesn't seem right, right? I guess this never goes to 0 because of the +1. But 2 doesn't make any sense either. Or does it? So we test for 1. Well, 2 is not meant to be inclusive. That's what I'm trying to think. Right? That's why we do tail is equal to mid. Why is tail 3? Did I do something weird? Because there definitely should not be 3 elements in the second input. This does get. Oh no, it should, because it's 0, 1, 2. Okay. But the 0 number doesn't. It should be just -1, but it still shouldn't. Because now we're using 1. No, that's not true. Huh. I'm doing something funky. So now, again, you get to see Larry debug binary search, which is always one of my weaknesses, because I get these weird off by 1 cases. So okay, so now it's trying to find a number between 0 to 4, not inclusive. It finds. Where does the 2 come from? Oh, that's from this. Whoops. Really need to label my debugging so it's less confusing. Okay. So for 4, it rolls a 1, so it should be just gives me a 0. So mid is 2. And confused. Isn't prefix of 2 should be. Yeah, the number is 3. So the prefix of, so this is bigger. Did I get the signs wrong? That'd be pretty embarrassing, but it's okay. So if this prefix number, let's say we wrote a 17, then we want to move the set here, right? No, that's right. It should be right anyway. Let's see, we rewrote a 3 and we see a 2, we should move for the head to 2. Except for that this is not true, right? Because if this is a 2, then this should be true, which means tail should be 2. And yet, somehow we return a 1. Yeah, how come we never pick a tail? Then, am I missing something really silly? Well, 2 is the last element, right? So if the prefix is, did I really actually just get the sign wrong? Yeah, I did, because I keep on saying that is just me being silly then. And somehow for these kind of problems, you really have to think about what you're asking. And even though I said it a few times out loud, and you're watching the video, you may be like, Larry, what are you doing? And you said the explanation, because I remember saying, like, if it's 18, then this is bigger than this number, which is, this number is bigger than this number. Okay. I don't know what. That's okay, as long as we eventually right. Okay, this looks. Excuse me. Oh, excuse me. This is recorded live, so we might or might not edit that out, but excuse me. But yeah, okay. So the thing with this problem is that it is a little bit random, so we can't really tell how if this is going to be true, even though we did, get it eventually. But it does look like it has, distributions in a good way in that, like you get a mix of both, which is not good enough for randomness. And this one, for example, is that true? I don't know. Is there any bias? It's hard to say, right? I mean, expected answer is just whatever, right? Okay, so I'm going to submit this, but the problem is that, so the problem with these things is that it is hard to test for random things that gives you randomness, and for that reason, because it's very easy to get bias. So definitely use a random library to do the things that you want to do, including sampling and shuffling and all that stuff, because you're very likely to get it wrong in a library. At the very least, you're in the same boat with everyone else. So because it's very hard to get it exactly right, there might be some biases, like off by ones or something like that would mean that certain numbers just never get picked. I'm a little, to be honest, I'm not super confident in this one, but it seems like at least for this one, all the numbers do get picked, or able to get picked. I mean, it takes a little bit of luck, but 0, 2, and 3. So that goes from 0, and it could pick a 4. So it knows that you could do the entire range. So that's how it gives me a little bit more confidence. And for example, maybe we could do something like this, and then it should be all 4s. I mean, you might still again get unlucky, obviously, but probabilistically, right? So anyway, so yeah, that's all I have for this problem. For interviewing, the first thing I would mention maybe just like, hey, if this was in the real world, I would definitely use a library because randomness is hard. on a competitive programming contest, I would just do it very specifically. Like I would just use this library without really thinking about it and be like, oh, next problem. But yeah, that's all I have for this one. Hope you enjoy me watching debugging. It turns out, so just be careful. My lesson here is just be careful with the signs. But I hope that binary search is hard, right? For me, especially. And even though this one actually wasn't a binary search for, it's just me saying out loud. I mean, even saying out loud, I was saying the right things out loud, but I converted to the wrong code, right? But I think the thing that I would say is that I actually got all the +1 and stuff correctly. And the reason how I would like to focus on that because as I mentioned before, there are a lot of focuses from binary search with memorizing these patterns. And like, look, if this is this, do this, and there's this pattern for it, right? And it's so cool. And then you have to memorize everything. And for me, it's just, I don't have enough brain cells anymore. I'm getting old. I can't remember all this stuff. So for me, it's about first principling a binary search and being like, okay, let's say head and tail. Let's say middle of this, right? And for me, I do the invariant and figure it out, right? Like, okay, let's say we wrote a number and it's 10. If it's 10, do we want this side or this side? Or this side? Inclusive or exclusive? And everything, right? And for me, I wanted to keep the invariant that the tail is exclusive. And from that, it leads to this where, the tail is exclusive, right? So we move it to middle when it's not possible to be here. So we want this side, for example. And then that means that here will never converge because that's just the way this goes. So the middle has to be +1 so that in theory, both head and tail can move, freely the entire range. And then from that also, because in that case, head will never be equal to tail. So then we do this head +1 is equal to tail. And then at the very end, I did head. In theory, sometimes it could be head +1 depending on what you're doing. But again, it all goes by the question of asking yourself, okay, I have this visualization. I'm checking the number in the middle or whatever it is in the middle. Is it on the left side or on the right side? And you binary search and you do it divide and conquer and you do it recursively, quote unquote. And that's how you do the binary search. Anyway, it's an okay problem. It's a known problem, so it's okay. But hope you enjoyed it. Hope you liked it. Hope you enjoyed watching me struggle. Hit the like button, hit the subscribe button. I'll see y'all later. Bye-bye.